Now let us understand how we can use derivatives to check whether a particular function is increasing or decreasing. So that is what here we have as increasing and decreasing functions. Now to begin with, let us understand couple of terms. That is, in the increasing function we can have two types, that is as shown here. It is either strictly increasing function or just increasing function. So by strictly increasing function we mean if x1 is less than x2, then f of x1 must be less than f of x2. So what it means is, say x1 is one particular value which is less than some another value, say x2. Okay, so if that is the case, then we should have f of x1, which is this particular value, to be less than f of x2, which is this particular value. Okay. So you take any pair of x1 and x2 where x1 is less than x2, then the corresponding functions values should also be having the same order relation. Alright, that is called as strictly increasing function. Now if we allow the equality in the functions comparison, right, in the strictly it was only less than, but now when we say just increasing function we allow the equality also. So in that case it means that at some point the function may remain constant, but otherwise it has to always be an increasing function. So that is what is shown in the second figure. Now if you consider x1 and x2 here as shown here, okay, then it has the less than inequality, correct? But if you consider x1 here and x2 also here, then in both of these points the value of the functions is exactly same. So that is where the equality holds, right? So that is the distinction between these terminologies. Now similar to increasing, we can have the corresponding two cases for decreasing function, and it's not difficult to understand what that would be. For a strictly decreasing function, if you consider some x1 and if you consider some x2, right, which is bigger than x1, okay, so in that case the inequality of the functions will be opposite. So in strictly decreasing function f of x1 should be greater than f of x2, whereas if we just say decreasing function, then for x1 less than x2 f of x1 may be greater than or equal to f of x2, right? So this is how we are to understand increasing and decreasing functions. Now to check whether a particular function is increasing or decreasing, what we have to realize is that when we say that a function is increasing, it means if we draw a tangent at some point, then the tangent will be going up. So in other words, its slope must be positive, isn't it? So if the function is increasing, its slope should be positive. So in other words, in this question, if you want to check whether the given function is increasing or decreasing, we should simply check whether the slope is positive or negative. If the slope is positive, it would be an increasing function. If it is negative, then it will be a decreasing function. So based on the function, we have to calculate the slope, which is nothing but the derivative, as we know. So f dash of x here is given by 3x square minus 6x plus 3. So we can take 3 common from all terms, so we will be left with x square minus 2x plus 1, isn't it? Now we want to check whether this particular quantity is positive, negative, or what. Now if you observe, this particular bracket can be definitely written as the square of x minus 1, right? Now we know that since x is a real number, x minus 1 the whole square will be definitely a non-negative number. So therefore it means that this f dash of x has to be greater than or equal to 0. It can definitely not be negative. Okay, so therefore since the derivative is greater than or equal to 0, therefore we say that f of x is the increasing function. if the derivative were purely greater than 0, that is if there were not equality, then we would have said that it is strictly increasing. But since the equality with 0 is also evident, we have to say that it is simply increasing function. Alright. Now let's go ahead and see another question. Find the values of x for which f of x given by 2x cube minus 15x square minus 84x minus 7 is strictly decreasing. Right? Now once again, since we are given that the function is to be a strictly decreasing function, we have to find what is that interval or the range of x in which the function strictly decreases. So since the function is strictly decreasing, we have to say that the derivative must be strictly less than 0, right? Now to get the derivative of this particular expression, first term will be 6x square minus second term is 30x and minus 84. The derivative of 7 is 0. Now we want this particular expression to be negative. Now we can cancel out the factor of 6. So therefore we are left with x square minus 5x minus 14 to be less than 0. We can easily factorize this further so that we will have x plus 2 and x minus 7 less than 0. So we see that we have a product of two terms negative, so that means we want either both negative or both positive, and this can be solved by what is called as method of intervals. So what do we do is, to make this first factor 0, x must be equal to minus 2, isn't it? And to make the second factor 0, x must be equal to 7. So we mark off those values on the number line. Right? On the rightmost side, we write plus. As we travel through the factor of 7, or rather the value of 7, the corresponding factor x minus 7, we check its degree. It is 1, which is odd. So therefore, while traveling leftward as shown, we change the sign from plus to minus. Right? Now once again we come to the left and cross the value of minus 2. Now we come to the corresponding factor x plus 2. Here we observe that its degree is 1, which is once again odd. So we once again switch the sign to plus. The idea behind this plus minus is that the region wherever we have written plus, that gives the inequality of greater than 0. But we want the inequality to be less than 0, which is given by the region where we have written the negative sign. So therefore it is this region in which the expression x plus 2 into x minus 7 is negative. So therefore x must belong to the open interval minus 2 to 7. We cannot include the values minus 2 and 7 themselves, because at those points the expression will become equal to 0. Right? So we can write the answer in other way in terms of inequality, that is minus 2 less than x less than 7. That is the answer.